Good afternoon, I am Mr. Ish. Thank you for joining me. In this video, we're looking here at the inclination of a line. That means the angle of a line with respect to your reference horizontal, which is normally the x-axis. If there were a given line and the line looked something like this, what would be the angle or the inclination of this line with regards to this x-axis? And we will learn how to do that. Very generally, there's a specific formula, tan theta is equal to m, which is your slope. If you can determine the slope, then you can calculate for this angle the inclination of that line with respect to your x-axis using this. You take the tan on the other side and you'll have arc tan of that slope, and that's the angle and the means by which you will go about with this specific video concept. We have an example over here already written out for you. We know the formula tan theta is very well related to the slope, and we have to determine the inclination of this y minus x line. Convert always into y equals mx plus b format and then go from there. I have y minus x equals 1. I have y is equal to x plus 1. You don't have to do these extra steps I will show you, but I'm doing them simply for the video. If x-axis value here was 0, y you know is a 1. If y value here is a 0, you know x will be a minus 1. When you plot this out, this is just us getting an orientation with regards to what we have. We have a minus 1 comma 0, 0 comma 1. We have a line which is looking like that. And what is this angle? And we have to determine that. When you're looking over here, what's the slope? The slope is an imaginary 1. Your m is equal to 1 because the coefficient of x is a 1. Therefore, tan theta is equal to m, which is equal to 1. Theta is equal to arc tan of that 1. And you know there's a specific angle. If you did the tangent of it, it's always equal to 1. It's 45. But we can verify it. We can just do 1 inverse tan. You get 45 degrees. So this angle over here is 45, or you can say pi over 4. And that right there would be your answer, 45 degrees, the inclination of this line. Very generally, in terms of inclination, remember this: vertical lines are inclined at 90 degrees. They don't have a slope, it's undefined. Horizontal lines have an inclination here of 0 because m is equal to 0. When you do the inverse tan of 0, you have 0 degrees. So these are your standards. Vertical is always 90 degree inclination and horizontal is always 0 degrees. We're looking at all of these non-horizontal, non-vertical type of examples in between the diagonal lines, for which you will use that tangent and the slope component formula which I presented to you. We have a question over here: what's the inclination of this line? Well, convert it into y equals mx plus b. 3y is equal to minus 2x plus 2. Minus 3y is equal to minus 2x plus 2. 3y is equal to 2x minus 2. And y is equal to 2 over 3x minus 2 over 3. We're looking right over here. But just from right over here, if you want to get an idea, if x were 0, you can solve for y. Your y would be minus 2 over 3. If y were 0, you can solve for x. You'd have a minus 2 and then x would be equal to a 1. If you were to graph it out, this is what you'd have: 1 comma 0 and 0 comma minus 2 over 3, which would bring it somewhere right over here. Right over here. And then when you do that, you're looking at this angle right over here. Sometimes you can have an obtuse angle and you always have to be aware of that. Anyhow, we have a slope over here of what? 2 over 3. M is equal to 2 over 3. Tan theta is equal to your slope, which is 2 over 3. Theta is equal to arc tan 2 over 3, and you got to determine that. Just do 2 divided by 3 and inverse tan it. 2 divided by 3 inverse tan, I have 33.7 degrees. The angle here is 33.7 degrees. Now, just before we end this video, because I've done my second question, be very well aware of this fact. If you have a line which creates an obtuse angle, something which was pointing in this direction, now you're looking always with regards to reference angle, you'll get something like this, 30 degrees. Now you will have to do an adjustment here from 180. If supposedly you had this specific question, you see you have a 2 or 3. What if everything worked out and here m was equal to minus 3 over 2? See how that would play out. You would have tan theta is equal to minus 3 over 2. This would be a case where you'd have an obtuse angle form, and then theta would be the inverse tan of this minus 3 over 2. Look how it play out. 3 divided by 2 minus inverse tan. I have a minus 56.3. I have here a theta is equal to minus 56.3, but I would adjust it from 180. I would do minus 56.3 and I'll add 180 to it and I'll have 123.7. In this case, you'll have 123.7 degrees. So not always can you expect the typical acute angle where whatever you get is your answer. Sometimes your line can create an obtuse angle with reference horizontal, then you have to adjust with this 180 degrees. You'll know that to be the case because you'll get an angle here in terms of a minus, which means you have to do some sort of adjustments. The two examples I've shown you have always generated a positive angle, so no adjustment was needed. So keep this peculiarity in mind. And that's all we're presenting with this video. Thank you for watching. Have a nice day.